Welcome to lesson video 2.1 on interval notation. Now, this topic is very important because we use it throughout the entire unit. Actually, we use this all year long. So this is a really good notation to learn. A lot of students actually like it better because it seems a little bit shorter and condensed. And the big idea is that inequality notation, which we've seen before, is very closely related to interval notation. So what do I mean by that? Well, inequalities, when we have a less than symbol, that means that it cannot equal. Or if we have a less than or equal to symbol, that means it can equal. And obviously the same would go for a greater than symbol or a greater than or equal to symbol. The same logic applies with interval notation. So when I have something that can't equal something, I use what we call open brackets. They look like parentheses. So that is what would be equivalent to a less than symbol. Then I have closed brackets, which means that it does include. So that would be the equivalent of a less than or equal to symbol, or a greater than or equal to symbol because it can include. Let's see it in action. So looking down below, I have the inequality 3 is less than x is less than 6. If I want to write this as an interval, basically I'm talking about the numbers from 3 all the way to 6. And I'm going to separate them with the comma, and since neither 6 nor 3 are included in this interval because they can't equal, I will use open brackets. Let's see how the next one looks. It's almost the same. We're still looking at numbers from 3 to 6, but you might say, Mrs. Ruscio, this can include 3 because x can be bigger than or equal to 3. So you guessed it. There's our closed bracket. But 6, sorry, not included. Therefore, he gets the open bracket or the parenthesis. On the flip side, we can have 3 is less than x is less than or equal to 6. Again, very similar. 3 to 6, only now open and closed. Hopefully you're seeing the connection. Just going to highlight that. And last but not least, again, 3 to 6, but since x can be bigger than or equal to 3, close off that bracket, and can be less than or equal to 6, close off that bracket. Another important piece is to know what numbers are included. And in this case, it's asking us to include the integers. So we're only worrying about the positive and negative whole numbers. So 3 is not included. The next biggest one would be 4, 5, but not 6 because 6 is not included. It cannot equal 6. X can't equal 6. Let's see what happens with the next set. So we have 3 is less than or equal to. So it looks like we can actually start with 3, go to 4, go to 5, but can't include 6 because can't equal it. Next set, we cannot include the 3, but 4, 5, and look, now 6 is included, so 6 is the highest integer. Now we can see the last number set where 3 is less than or equal to x all the way up to less than or equal to 6. We can include both 3 and 6 and all of the numbers in between. All right, that was fun. Let's see now graphs of this. So the next set of directions ask us to write the inequality below using inequality and interval notation. Okay, so the first thing that I like to identify is where do I start, where do I end, where do I start and end for each one of my graphs. I think this is really helpful. Sometimes it will go actually to infinity or start at infinity. That's if we have arrows on either end. But let's just look at these closed intervals right now, the ones that kind of start and stop. Okay, so looking here, if I wanted to write this in interval notation, I'm going to just list the beginning and end numbers, so -5 to -1. Then I'm going to take a look at the point. Since -5 is not included in my number set, I am going to use an open bracket. -1 is, so that bracket will get closed off. And if I write this in inequality notation, hopefully we know how to do this by now, but if not, let's just do a quick review. We start at -5. It's always a less than symbol to make the inequality statement true. And we'll use x is less than or equal to -1. Again, because -5 cannot be equal to x, but it can be equal to -1. Number 2, let's do the inequality notation first. So we're going from -1, since it is a closed point, it can equal. So less than or equal to x is less than, and in this case it can equal 3, so less than or equal to 3. Interval notation, we list from -1 to 3, and since both of those numbers are included, they can equal those 2 points, those endpoints, we use closed brackets. Try number 3 on your own, see how you do. Since we cannot include either the -2 or the 4 endpoints, notice how we use less than symbols and open brackets. The next 5 questions we need to graph. This is a really nice review of some of our prior concepts that we've learned probably at the middle school, stuff that we talked about in Unit 1, and now tying it into our interval notation. So number 1, hopefully you are able to read this. This says x is bigger than or equal to -3 or greater than or equal to -3. So since it can equal -3, we're going to fill in the point, and now we need to look at all the points that are bigger. So we shade or draw our arrow to the right. Number 2 says -3 is included, so that means we are going to use a filled in point, but 2 is not. So we're going to have an open point at 2. So -3 filled in all the way to 2. What it will look like is just shaded in between. Number 3. 3 is less than x. Okay, so let's put our open point at 3, since we know we can't have 3 included, but it gets really close, and it goes all the way up to 6. So there we have our filled in point from 3 to 6. Number 4, both -2 and 3 are included. Therefore, we'll have a filled in point here and there. And we're going to shade in between them to model that all of the points in between -2 and 3 are included. Lastly, number 5, both points appear to be open at -5 and -1 because we can't equal them, and we shade in between. The directions in questions 6 through 9 tell us that we need to convert each situation into an inequality, then write it in interval notation to make the connection between the two. So number 6 says, in order to ride a certain ride at the fair, your weight, W, they're giving us a variable, must be at least 35 pounds, but under 200 pounds. Okay, so we know that the lower limit must be 35, but the upper limit is 200. And since W is the variable they asked us to use, let's put that in the middle. The symbols will always be less than symbols when we're talking about a range of values. But what we need to find out is, can you weigh 35 pounds? Well, at least. So at least, yes. If you weigh 35 pounds, you can go on the ride. So we're going to say equals. And then we need to be under 200 pounds. So under 200, well, if you weigh 200, unfortunately, you won't be able to ride this particular ride. So we are going to leave that a less than symbol. Your weight cannot be equal to 200. Converting this to inequality, or converting the inequality notation to interval notation, we are going to range from 35 to 200. 35 is included, 200 is not included. So closed, open. Number 7. The scores X on a test range from 75% to 97%. So it looks like the scores of 75 and 97 were both included. So 75 is less than or equal to X is less than or equal to 95. And if we write this in interval notation, 75 is included, so there's our close bracket, all the way up to 90. Where did I get that 95 from? That should be 97. I need to go back and fix that. So 75 to 97, they actually did better. So that should be a 97. Sorry for that confusion. All right, let's go on to 8. The temperature F of the compound must be higher than 65 degrees. It must be higher. This temperature F has to be higher. Doesn't seem like it can equal, but no more than 70 degrees. Well, no more than means it can equal 70, but it must be below. Let's convert this to interval notation. 65 degrees Fahrenheit is not included, and that ranges all the way up to 70, which can be included. Lastly, the speed limit Y on the expressway must be at least 55 miles per hour. Okay, so at the very least, that means it can equal, Y can equal 55, but you can drive at most, which means you can drive 65, but under 65, it can equal that. So 55 is less than or equal to Y, is less than or equal to 65. And since both 55 and 65 are included, that means we get to use our closed brackets. Okay, so I'm hoping that things are getting very repetitive by now, that I'm almost overdoing it. That's good. That's a good sign. That means that it's sticking, and it's good because we need to know this for the entire unit and the entire algebra course and probably beyond even. So let's get the practice yet again with the inequality interval, and then we're just going to add that extra layer that we did at the very beginning to tie it all in together to say that certain integers can or can't be contained in the set. We're going to list all the ones that are in the set. So number 10, we're given the inequality. It looks like both -2 and 5 are included. So that means you got it. Close those brackets. That means -2, -1, all the way up to 5 are included in this awesome set. Okay, number 11. We're given the interval. We have to go back to inequality. Let's just use X. It didn't really tell us, but it looks like that's what they've done on the rest of the questions. Since 7 is not included, we're going to leave that a less than symbol, but 11 is, we are going to make that a less than or equal to symbol. Well, 7 is not included, so it looks like we have to go from 8 to 9 to 10, and is 11 included? It sure is, because it can equal. All right, next one. 15 is our lower limit, and 18 is the upper limit. Neither are included, so open brackets for both ends. 15 is not included, so that means 16, 17, 18 is not included. Only looks like 16 and 17 are my integers. Okay, I'm hoping that you're getting the hang of it. I'd like for you to pause the video now and try 13 through 17 on your own. Good luck. So here you have it, the answers to the questions you just completed. Take a minute, pause the video, check your work, make sure if you have any questions you bring them with you to class the next time.